I'm Steve Ickman. Welcome to the first ever, I believe, TypeScript meetup. So with TypeScript out in the wild, I just figured it was probably a great time. There's a lot of teams in Microsoft already using TypeScript. There's a lot of teams that want to use TypeScript. Quick show of hands. Who is not using TypeScript yet on their projects? Okay, so there are a couple of guys that need to be inundated and convinced to use TypeScript, right? Bashed into it. So actually, I'm with Fuse Labs, and we're like huge fans of TypeScript. We've been using it for 6 to 8 months now. And we'd love to see additional teams across Microsoft and people outside of Microsoft adopt the language. So hopefully we can do something like this every quarter or so. But let's get things started. So to begin with, the agenda, the afternoon is kind of broken down into 3 parts. We're going to do a quick round-the-room set of introductions, followed by a few presentations, and then leaving a bunch of time for us to just talk and socialize. There's food and beverages outside for after the event. It's scheduled to stop at 5, but I think we have the room for as long as we want. So if you guys are talking, feel free to stay and talk. So let's get things started with the introduction. So the way we're going to do this is the way that we always do this in most of our meetings, is that just give your name, what team you're with, and 3 words that kind of describe you. So I will start. I'm Steve Ickman with Fuse Labs, and my 3 words are programming, TypeScript, and audio file.
I'll give it to Anders.
I'm Anders Hejlsberg. I'm well, my 3 words, I guess, is what .NET, C# and TypeScript. Chief Type System Randomizer. Yeah.
Okay, I'm Steve Lucco. I'm going to go with Chakra, TypeScript, and JavaScript.
I'm Akash. I'm a dev on TFS. I'll say web access. So TFS web.
I'm Rajiv. I work in the Fuse Labs. The 3 words, .NET, C# and TypeScript.
I'm Ian Obermiller. I'm also a dev in Fuse Labs, and I would say Fuse programming languages.
I'm Gleb Krivoshev, and I'm going to work on Skype pretty soon, so my keywords would be, let's see, C#, SQL, and sailing.
Todd Newman. I'm in Fuse Labs, and I guess my 3 words would be coder, parent, and guitar player?
No, that's 4. Guitarist.
Dan Marshall in Fuse Labs, developer. UX craftsman. I'll just stick 2 words.
Thank you.
Luke Hoban, work in DevDiv on TypeScript. 3 words would be JavaScript, standards, and tools.
My name is Kevin Clement. I'm a developer on OWA. 3 words would be programmer, dad, and probably Warcraft.
Tom Laird McConnell, Fuse Labs. My 3 words, cowboy, ninja, pirate.
Oh. Lily Chang, girl, social software design.
Sorry, Tom Ball. Research and software engineering, Microsoft Research. Researcher, bassist, singer.
My name is Pelly. I work in the TouchDevelop team. I would say I hate Firefox right now.
I'm Michal Moskal. I'm also at the RISE group at MSR, and I guess programming languages research.
I'm Emil Madoun. I work in Windows Phone, so I guess would be music, Windows Phone, and web.
I'm Nicola Tillman. I'm also in the RISE group at MSR. My 3 words are TouchDevelop, PEX, and Azure.
Hi, I'm Cyrus. I just joined the TypeScript team on Monday, so this is actually a really good meeting for me. I guess my 3 words would be passionate, languages, and IntelliSense. So.
Hi, I'm Johannes. I'm from the Zurich dev team. I work on Monaco, and my 3 words would be TypeScript, Monaco, and Zurich.
Hi, I'm Eric Gama.
My three words are Monaco, programming in the browser, and I will not say patterns.
Hello, my name is Dan Rogers. I'm a dev on the Xbox Music team. I would say my three words are programmer, gamer, and dad.
Eduardo from the MSDN, programmer, web, and games also. We're going some kind of introduction.
I'm Kyle Prosser. I'm just interested in the area of JavaScript cross-compilers, even though I've typically hated JavaScript in the past.
Have we done the front table yet? No. Okay, so let's get these new guys that came in and don't have a clue what's happening. And then
Hi, I'm Jason. I'm about to actually join the TypeScript team very soon.
My name's Pete. I'm a developer on the SharePoint team, so I use JavaScript a lot.
Hi, I'm Rahul, also a developer on SharePoint. And yeah, we've been exploring trying to use TypeScript for some of our UI work. Okay, I can wait.
3 words, you guys.
Hi, my name is Henry Tan. I'm a dev from Socl AIP Analytics. So 3 words for me, I guess: Messenger, Bing, and SQL.
Kevin Grealish, Dev Lead, Data Lab in SQL Organization, Advanced Data Analytics.
Hi, I'm Randy. I work with these guys in SQL's analytics thing. My 3 words will be Chief Problem Complainer.
My name is Rick Weber. I work on AIP with these guys, and my 3 words will be what he said.
Hello everyone, my name is Gibson. I was a former C# MVP, now working for Socl. My 3 words could be C#, Socl, and JavaScript. Thanks.
Hello, I'm Krishna. I work for Socl Group. My 3 words are, well, JavaScript and algorithms.
I think we had a couple of stragglers come in, so...
Hi, I'm Wolfram Schulte. I was in research. I run now a new team, Tools for Software Engineers, and we are exploring TypeScript as a build scripting language.
Awesome. And then Chris here at the back, real quick.
What's the instructions?
Just your name, group, and 3 words that describe you.
This is a lot of pressure. So my name's Chris Dias. I'm on the Monaco Tools team. Did these 2 guys introduce themselves already? Yeah. All right, so I'm the Redmond guy for these guys that are in Switzerland. 3 words that describe me. Ex-VB guy.
Okay, that was awesome. And just so that everyone knows, this is being streamed live, and it is also being recorded for later. Everything is Microsoft confidential, just assume that, and so don't go blogging stuff afterwards. And let's turn it over to Anders.
Should be, yep, there we go. Wow, well, wanted to first say thanks to Steve for putting this together. This is, like, it's not often that you have someone else put together the thing that's going to talk about your product, you know, so that's very nice. And I want to thank all of you guys for having been, at least some of you, very early adopters of TypeScript and suffering through the pains of changing whatever it was we were changing, whatever week we changed it, you know, like why don't we do a new class model, for example? So that's been great, and it's been super valuable for us to have real-world users. There's nothing like real-world users to inform dumb decisions you make and get them straightened out in a hurry. So maybe a little bit of history. Maybe Steve can join in. Steve and I have been collaborating on this project all along. Steve is, as I'm sure you know, is like the technical fellow and in charge of the Chakra JavaScript VM. And then we worked together on the TypeScript project with Luke and a whole team of excellent folks. And it's been an interesting ride. I think, you know, the genesis of this was really sort of, we all could see how you know, the world was moving from, shall we say, a very homogeneous environment with PCs everywhere, where you could just sort of target the 90% of the market that was PCs and then ignore the 10%, and therefore you could just stay happily in Microsoft's ecosystem and not really worry about the rest. And the world has changed, and I don't think the world will ever go back to the old world it was, right? And so more and more we're looking at a heterogeneous world of devices and tablets and PCs and what have you. And so cross-platform, you know, obviously becomes more and more important unless you want to engineer everything 3 or 4 times. And that in turn means, you know, that we need to get more serious about cross-platform. It's also interesting to note that the players that, you know, the one big player that traditionally represented cross-platform, i.e. Java, is actually no longer cross-platform either. So the rules really have totally changed, right? It's not just that we swung back over to cross-platform, it's also that we eliminated the major player there from cross-platform. And the only thing that's left, if you will, by process of elimination is JavaScript. A thing that was never really intended for what we do with it now, right? And that's the challenge, but that's also an opportunity, obviously. And so 2 or 3 years ago, when we were looking at, you know, what do we do for JavaScript development? Everyone's screaming at us how hard it is, and our tooling sucks, and we don't really have anything, and there was a lot of talk about, well, maybe we should productize Script Sharp, for example. Teams internally have used Script Sharp with great success. But we also felt that if we did that, we would effectively acquire 0 net new customers. It would be a play to the gallery, you know, a way to keep our existing customers, internal or external, happy, but we would effectively never interest any of the cool kids or people who've sitting there with their MacBooks or what have you, right? And I think also, you know, I mean, in sort of, in the interest of being very honest with ourselves about what is the best we could possibly do for JavaScript development, I don't think the best you could possibly do for JavaScript development is develop in a different language with a different framework and cross-compile it to JavaScript and have everything be at arm's length, you know, a distance from you, and every time you want to use a library from the community, you'd have to first encapsulate it or do whatever. And so we had a bunch of these conversations and decided that really, you know, ideally what we want to do is somehow fix JavaScript's problems, but the challenge is fixing it without actually taking away the thing that makes it interesting, i.e. the cross-platform and so forth. We also thought in the beginning that maybe this was going to be about, you know, we knew it was going to be about a better tooling experience. But I would say in the beginning we were a little bit confused about what the value proposition was going to be. Was it going to be performance? I mean, in a sense, I think we started out thinking that, you know, the thing that was really going to kick butt here was that we could like somehow like support integers and whatever and generate code patterns that informed the VM, you know, so it could generate better code in the JIT, and there was a lot of sort of going around with that, and there was also sort of the learning process for us of truly deeply grokking A, what the JavaScript community is about, and B, what the JavaScript language, how it works. What is the type system of JavaScript? I mean, we sort of kind of knew that it was odd and had like these functions that you could have properties on too and whatever, but how do you actually like formalize that, and what is it? You know, and so I'd say the first 6 to 9, maybe even 12 months were slightly confused. You know, although I mean we could do good work. Steve in that time wrote a JavaScript parser in JavaScript by porting the Chakra parser, and that was great, and that gave us a foundation to start on top of. But gradually we sort of came to realize what it was that we wanted to build, and really the thing that really has flipped here and also has made it a very interesting exercise is that I mean, the key value proposition we bring, I think, is the static typing or the optional static typing, because that is the deep enabler for the intelligent tooling that, in turn, is what makes it all worthwhile and what gives you the ability to do application scale JavaScript development, right? I mean, classes and modules, of course, are wonderful, but ECMAScript will have those, but even once it has those, you know, we'll still add tons of value. I mean, the real value we add is the enablers for the intelligent tooling, and that it turns is. So, and that meant, you know, that the static type system was something that was important to design, but it's been very interesting because in TypeScript, the type system is really not a type system for any of the classical reasons that you do type systems, like be it correctness verification or performance, or, you know, there's some of the correctness, there's none of the performance, but there's a lot of, I mean, almost all of it is type system for tooling's sake, right? I mean, and that's actually been very interesting, and I think we've actually also sort of come to much better understand what in today's programming endeavor, what is it that makes type systems valuable? And it really is the toolability, I think. It sort of swung around. You know, it used to be a different thing, like performance and whatever was why we had type systems, but we can get great performance without type system. Heck, I mean, Chakra on V8 proves that, right? But productivity for, you know, programmer productivity can dramatically increase if you do your type system right and integrate it right and whatever. And so that's been very interesting, and that has made us made a bunch of decisions very differently. It's also very liberating because you're designing a type system that doesn't have to be provably correct and doesn't even have to be correct. I mean, I don't even know what correct means for this particular type system, right? I mean, because it's full of holes. It's like the Swiss cheese of type systems. But it's darn useful, right? I mean, but it has to have holes because you need to be able to crawl out of those holes and do your JavaScript coding and then come back in another hole, you know, and so, yeah, bad analogy, but anyway, those are, I guess, some of my thoughts. I don't want to steal too much time. I think we should turn it over to Luke, and then Luke will recap, you know, sort of what has happened in the last month or so since we've gone public with TypeScript. And so, yeah. Thanks, everyone.
Are you on? All right. Okay, there I am on. Yeah, so I wanted to just spend a few minutes talking about, we obviously put out the first public release of this, of TypeScript a few weeks ago. Yeah, we were actually very happy with the reaction we got to it. So I wanted to share with you some of the things that we saw coming out of that release. And then also give you, we're actually planning on having our next milestone update release next week, the M9 release. And so I'll give you a little bit of an overview of what we're doing there, and show a demo of one of the new features we've got. So in terms of the release, so one of the interesting things is we, whenever you're building a new tool, like a new language in this case, especially a new language that's going into the JavaScript developer community, one of the things we were obviously very aware of was that there's a lot of interesting politics going on in this community, and if we just went and said, here's our brand new brilliant thing that's a proprietary tool that ships in VS and isn't open source, that we probably would get a cool reaction, and that's probably putting it mildly. So we actually put a lot of effort into thinking about how we would design a release that would actually enable us to sort of get a broad awareness in the JavaScript community and to really attach the idea of TypeScript to the thinking about large-scale application development. So if a JavaScript developer out there, no matter what platform they're on, no matter where they are, if they're thinking about, you know, I need some tools that will help me with large-scale application development in JavaScript, we really wanted to associate TypeScript into that. And so obviously, yeah, so this is, you know, the website that we put together. Some of the things that we sort of brought to bear on this, we obviously had that website. That gave us a nice sort of landing page for everything. The Monaco-based playground, how many folks have used the playground experience? Hopefully most, okay. So the Monaco playground, built by these guys back here, is just an absolutely fantastic asset for us. It means that people, no matter what platform they're on, no matter what machine they're on, can go and get an experience with TypeScript right away. It meant that a huge number of people who wouldn't otherwise have spent the time to download the tool were able to build up a quick understanding of what it was about and an impression, and that led to a lot of, I think, the cycle of actually getting some reactions on it. And of course, we had the VS 2012 add-in and the npm install as a cross-platform experience. The project is open source. That was also received very well, and so we had the open source project on Codeplex. And then we brought several assets to bear here. Some of the notable things, the Microsoft OpenTech organization actually helped us by building some of the plugins for using TypeScript inside VI and Emacs and Sublime Text, which aren't nearly as rich, obviously, as what we can do in Visual Studio, that we can do in those tools. But it did mean that it provided at least a baseline experience for folks on those platforms to use TypeScript, which again was one of the things that enabled us to get a lot more engagement on these tools. So sort of a few different things we were targeting. The first one was sort of this awareness and mindshare thing, and I'd say this was the one we really were focusing on in terms of how we did the release. There's some sort of random big numbers up there that we were fairly happy with around visits. One interesting thing, the video that we have on the front page there, Anders' overview of TypeScript, has been quickly rising the ranks in Channel 9's most watched videos ever. So it's at 25. Well, it was at 25 last Friday, but it's been going up a couple slots every week still. But I think the really notable things here were, this number was the one I was actually most impressed with and happy that we managed to accomplish. That if you're building something for JavaScript developers, Windows is probably even actually a minority for the front-end developer community. And so really getting broad visibility amongst a broader audience there was important. So the stats we have for TypeScriptLang.org are that we have 33% non-Windows visitors to that. So we did appeal outside of the core Windows users. And that was notable because things like WindowsAzure.com, for instance, so some of our properties that we are even trying to really push outside of the traditional Microsoft audience are really still struggling. We as Microsoft are struggling to connect with a lot of these developers. And so this is an important piece along that way. We got a lot of the sort of significant influencers in the JavaScript community to sort of comment on TypeScript, and most of that was sort of neutral to positive, with a fair few actually being quite positive. Doug Crockford wrote up a thing. He actually had some very nice things to say. I should add to this that he obviously did at the end say, this is great, but it's not something I'm going to use, right? But that's Doug, and Cyrus is reading the good parts there, right? But Doug obviously has a very particular viewpoint on these things. But it was great that he's been very negative, obviously, on Microsoft in times. And so the fact that he understood the value proposition of this tool and was positive on it, and so were many of the other major sort of vocal figures in the JavaScript community, that was something that we were obviously very happy to see, and spoke a lot to the core value proposition of trying to help large-scale JavaScript development was something that is well received in this community. And even some of our direct kind of competitors, really, this was just private email that someone sent me, but someone from the Chrome team, obviously, you can't ask for much better than clever, elegant, simple, and compatible. That's sort of a strong positive there. The next thing which we were really interested in starting to enable, but I think there's still going to be a lot more work that we're doing sort of in the external community and also in the internal Microsoft community on this, is sort of the ecosystem aspect around TypeScript. So we've done, we've gotten a lot of engagement on the forums and things. I know several folks here have actually helped with answering questions on the forums and things like that. That's been enormously valuable to have that sort of interaction going. A couple of the interesting things, we've seen a great ecosystem around tools that sort of build around TypeScript. So plugins into a lot of different sort of server and build processes, so Ruby and Grunt, ASP.NET obviously, some compiling client solutions. And so we were seeing a lot of these even just a couple days after the release, that people were already throwing up on GitHub or whatever, the connections into whatever various ecosystems there were. Probably even more interestingly than that, from the tools side, I don't know how many folks saw this, the Cloud9 IDE, which is a web-based IDE, They shipped basic, very basic support for TypeScript 2 days after we released TypeScript. So less than 48 hours after we had it out there, they were actually advertising that they had support for this inside their tool, which was good to see. And we were at a conference in Berlin as part of the sort of announcements of this, and there was actually a guy from the Cloud9 team doing a presentation there. He'd actually changed his abstract to talk about to mention TypeScript, and then spent about a third of his talk actually describing why TypeScript was so good for, powering tooling, right? So they were obviously excited about it. And in IntelliJ's tooling, TypeScript was the second ranked thing. I think they've now released a preview that actually.
Since these slides, they've actually announced support in their latest.
Yeah. So we're seeing some of the tooling vendors also take this seriously as an opportunity for them, just like it's obviously an opportunity for us to build richer tools for people building large JavaScript apps. I think some of the other tools vendors are seeing there's an opportunity there as well. And then obviously the last thing, which I think is the one that folks have been most interested in a sense, is the TypeScript obviously benefits from having typings. And so you can use jQuery or you can use whatever library you want without any library typing. You can just declare it as being in any and then work with it. But you get so much more value if you have a description of the API surface area that accurately represents it. And so one of the sort of things that was going to obviously swing, like, is TypeScript useful or is it really useful, is whether you have a good library of d.ts typing so that whenever you're about to use some existing JavaScript library out there, you're likely to be able to find the d.ts file or find something that's at least very close to what you need. And so we were very excited to see that there was sort of a community-driven effort around building up a bunch of these typings. I think this number is up to like 76 or something that we're aware of that are out there, d.ts library typings. And this covers, importantly, we looked at some of the surveys of the top JavaScript libraries, and just the ones provided by the community so far are covering 90% of the top 20 used JavaScript libraries. Yeah.
Libraries aggregated anywhere?
That's a great question. So there is a site, a guy on GitHub has a definitely typed project where he's aggregating these. And so people are sending him pull requests, and he's just maintaining a list of all these. Most of the ones that we're aware of here are linked off of his site. Right now, I guess I should at a high level say, right now we're leaving this as sort of a community-driven process to see how much energy the community can build up around this. We definitely expect to do something in this space ourselves as well, and to work with these guys to make sure that their investment is also leveraged into that. But we certainly do hope to be able to provide a more integrated experience for how you can discover and acquire these typings. But for right now, just given 4 weeks after we got the initial release out, we're actually very excited to see that there's both the creation of the library typings and also some of the aggregation going on. There's also a guy who built a tool that is actually kind of like an NPM tool, but for these library typings, where you can, from a command line, search for a library, and then you can download directly from that tool. So we're seeing some of these things being built by third parties. I think we're interested in seeing where that goes, seeing if we can, whatever we can do to just help that process keep going in a lightweight way, and then obviously have a more integrated solution at some point in the future. There was another question, I think, but maybe it got answered.
You infer the types the way that like a sharp does?
Inferring the types. So one of the questions we've gotten a lot, and it's sort of one of the top requests on the Codeplex tracker is I have a JS file, can't you just tell me the types, right? And of course, in a sense, if you think about it, if we could do that, then we wouldn't need to do TypeScript at all, right? We'd have all the information. You wouldn't need to tell us it. But it turns out that information just isn't there, right? The source code actually is not self-documenting about what the intent of the API surface areas is, right? Now there is some that we could probably, we could build tools that were somewhat heuristic that inferred some amount of the surface area. They could infer a lot of the names. Probably they'd be left with a bunch of any's. But they could infer some amount of that surface area. And I think we're interested ourselves in looking at some of those, but we're also interested in seeing what folks can build, because this is never going to be a full end-to-end answer, because it's going to be something where you kind of it has to be a heuristic tool. We're kind of interested in seeing what competing approaches people can come up with in terms of how they make that process easier. But it is something we're definitely aware of, and I think making that process easier is a goal that we have. But unfortunately, it's not going to be as easy as just press a button and you get a library typing out, right? That was the last question, I guess. Yeah. Okay. And then the sort of third one here is obviously the adoption aspect. For adoption is something that I think we're obviously a preview right now, and so we're not yet ready to really drive sort of broad. We've seen a lot of excitement around it, really to drive broad adoption, because if we have a lot of folks across the developer community using TypeScript at large scale, then we're going to have to manage all of them as we go through a breaking change process over the next several months. But we do want to see sort of the core adoption cycle starting to go, so that we can make sure we're getting all the feedback. There's some numbers up there. One of the notable things, we believe we've crossed over the 500,000 lines of code internally line now of people using TypeScript. And as Andrews mentioned, I think that's a really critical thing. If we it's really easy to build a product like this and not really have a whole lot of actual experience with what it feels like at scale. One of the challenges, if you're building a tool what it's supposed to be good at is building things at large scales, that means that to validate that, you actually have to find code bases at large scale that are willing to go and take a bet on some tool that is in development. And I think that the fact that we're able to find a bunch of teams internally, the Monaco guys were very early on and have weathered the storm the most, but obviously some of the guys at Fuse as well have been using TypeScript for quite a while now. And everyone else, I think, who's been using TypeScript, it's been an enormous benefit to us to have those internal code bases. One fun one over there, again, sort of a competitive thing, but these guys did a talk over at Facebook's offices in Seattle and broadcast it down into the Bay Area. And got some really positive feedback even from folks inside Facebook about TypeScript. So I'll talk just very briefly about this. This is very high-level thinking, and don't take this as commitments to anything. This is just sort of how we're positioning, thinking about some of our work. We have a v0.8 train that's we started that with the release we did in last month. The major things we're doing here, addressing some of the critical release feedback. We obviously got a ton of feedback on us when we put the stuff out publicly, addressing that. Debugging and some of the foundational pieces to make sure that we can have a good Windows 8 application story. It's possible today, but there's a bunch of holes in that experience that we really want to fill in and make a bit smoother. The 0.9 timeframe. One of the things we're definitely aware of is that there's a few pieces we have a type system that can express a lot of the sort of core JavaScript API patterns. There's a few things that we're aware of where we could make that a much more sort of faithful representation of what the API author intended. So things like generics. We know if we had generics, we could more faithfully represent the intent of a large set of APIs. And there's a handful of other things like that where we think we can capture those API typings better if we can do a couple of things more in the type system. So that's a key thing, so that we can make sure that we have a stable system for which people can build these library typings on top of. The other one is tool scalability. We already have a couple of code bases that are over 100,000 lines of code. We're starting to see that our Visual Studio support at that scale starts to feel sluggish, maybe is generous. And so we have some work we need to do to make sure that, just sort of some base compiler work to make sure that our tools can really scale up to the really large scale applications that we know TypeScript's going to be used for. And then the longer term piece is obviously we're building on top of some ECMAScript 6 features, and ECMAScript 6 isn't done yet. So as that changes, we're going to need to do a little bit of alignment work there. One of the nice things about having TypeScript out now is that we can actually use TypeScript as something to help drive the standards body as well. We have a lot of experience now with what it's like to use ECMAScript 6 classes and to use the module system that we have, which is very close to ECMAScript 6. And so the next standards body meeting's in a few weeks, and we're going to actually be taking a bunch of data that we've gathered from you guys and from other folks using TypeScript, and sort of present that and make a case for where there's a couple of changes needed to align with some of the things that we think are better to do there. And then the next wave of Visual Studio, we have a set of alignment things we need to do to get in shape there. So what I wanted to do was just, so we have the M9 drop, which is via 0.8.1, which is coming out next week. We're just finishing up engineering on that right now. The primary goal of that has been addressing this top external feedback. As I mentioned, we got a big wave of that on us, and so making sure that any of the bugs that we had that were really blocking folks coming from a different bunch of perspectives, that we get fixes in for those. And then the one significant feature it has is the source map support. So some of this had been implemented previously, and we had it in the compiler, but it was marked as an experimental flag. Of course, we're open source, and so people found that out and wrote blog posts about exactly how to use it. And
there is no such thing as experimental.
And so, which is fine. And so people were using this, but there were a bunch of things that weren't finished about that implementation, so we finished that off. But more importantly, we've added Visual Studio support for source maps. So for folks debugging using, and I see Randy's happy about that. But for folks using Visual Studio as their debugging environment, in particular, this is really, really critical for Windows 8 if we want to support the Windows 8 scenario as well, where you have to use Visual Studio as your debugging tool. Then having the Visual Studio support for source maps and for TypeScript is important there. So I wanted to quickly give you a glimpse of what that looks like. So I guess here I have my Win 8 app. So this is one of the samples we ship with, is the Encyclopedia Windows 8 application. For those who haven't seen this, it's just a basic Windows 8 app, but it has TS files with their JS file nested underneath them here. The notable thing, of course, is that I can come and set breakpoints in here. So now I'm in my TS file, and I can just set breakpoints. That's something, obviously, you can't do in the bits that all of you guys are using right now. But more interestingly, when I hit F5 to run this, we hit a breakpoint inside my TS file here, and so now I can step through the code here. There we go. Yep. And so a few more things here. So if I come into this constructor, so you get the call stack here, and you notice that this is a mix of so this file here is in base.js, which is JavaScript, and this is in TS. The one thing we don't have yet is it still lies and says this is the JavaScript file, but the line number is the correct TypeScript line number. So you actually do get the. This turns out to be a sort of a hole in the extensibility APIs for the VS debugger here. But this is something that we're going to get fixed in VS in the next release. But yeah, you get the call stack. This can have obviously mixed frames between your JavaScript. You can step easily back and forth between JavaScript and TypeScript, just like you'd expect. And if you hover over things like elements, because it's all just JavaScript and the names are all just the same as the JavaScript names, all of that's just straight there in the experience. So kind of just what you'd expect there. And if I go, if I search, for instance, oops. I did something to crash my app. Oh, I don't have an internet connection. But you see that that one didn't show up very well because I was just going to show that you can drop back into like callback handlers, and obviously all of the sort of spans within functions are supported just like they would be in JavaScript. So yeah.
So if we want to debug our live site, Chrome is still supported as well.
Yes. So I'm showing here Visual Studio debugging against the source maps. But one of the benefits of using source maps is that they are supported also in Chrome, and there's work going on to support them in Firefox. And so if you're debugging using any tool that supports source maps, we might even support them in IE someday.
Do you know anyone they're talking about?
We're working on that. But yeah, and I think because they're also supported in several different tools now. I think it's likely that we'll start seeing additional things like minifiers potentially supporting, including the transferring the mapping information from the source out to the output and things like that. So having one format there that we are standardizing tools on top of and supporting in TypeScript will help the ecosystem around that to become a bit richer. So we're excited to see that. But yeah, so if you're debugging with Chrome for your development, you can leverage this as well in Chrome's tools. So that's it for me. But thank you guys again for coming to this.
Okay, so I think we're going to transition into a Q&A session with Luke and Anders, and we'll bring out another chair, and we'll bring Steve up too. Okay, so do we have any questions from inside the room?
Well, if we're doing thanks, I want to say thanks for building the dark thing.
Okay.
You're welcome.
There you go.
Yeah, so Pelly, in the TouchDevelop team, we have 40,000 lines of code. So do you have some best practice in terms of architecturing how you reference all the files in order to have an incremental build, maybe an IntelliSense that a bit faster? Right now we use big ref files in every subfolders, but is there a better way to do that?
There are a couple of things. I mean, so I think typically we tell people to sort of have one master file with a refs to all of the files that then reference back to the master
That's what
file.
we do.
Sort of, yeah. I think you can also, I don't know, well, if you're at 40,000 lines, you're probably starting to feel sort of a bit of sluggishness on statement completion and whatever, red squigglies, which we all know, and then we'll work on fixing that. I think one thing you might experiment with is generating declaration files for sub-projects. If you divvy your project into sub-projects with a well-defined interface to the rest of the project, you can compile those, make a declaration file for those, and then sort of carry on just with the declaration file when you're developing the stuff that consumes it from above.
Would that make the IntelliSense faster?
Yes. Because you might, for example, let's say you have a subsystem of 20,000 lines of code. Mm-hmm. If you generate a declaration file for that, I'm just sort of going to guess maybe it would be 1,000 lines. You know, because it will only have the public members in it and nothing else. And now you could consume that, you know, across the boundary, and then, I mean, I've you know, just to consume like the TypeScript compiler, for example. If you compile a TypeScript compiler and generate a declaration file, it's a tenth the size. The TypeScript compiler itself is a megabyte. The declaration file is like less than 100K. I think.
I mean, sure, but I would imagine that if you just, if you just have IntelliSense, then it would just compile the one file that you are working on and not all the other files that you have opened.
No, so first of all, this is all temporary.
Yeah.
We're building an incremental compiler. We've hired probably the best incremental compiler person in the company, at least in the top 5, Cyrus.
Yeah, I think he's number 4, actually. Yeah. Is
So
that right?
Cyrus is coming on board. It's going to take him some time to ramp up, but then we're in the late this year and in the spring, we're going to do the push on this and get it there to 1 million plus lines kind of thing. So what's happening now is the most pessimal possible thing, which is that every line of code that is in your reference set, which you will know what your reference set is by looking at the virtual project. So if you're using a project file, you know what your set is. If you're not using that, you can look at the virtual project if you open the Solution Explorer, and you'll see what files are in the reference set. And we're recompiling all of those files and retyping, checking them every time you type dot.
Every keystroke, yeah.
Okay, so it's as bad as it can be. Now,
it can only get better.
We have a strategy that I completely believe in. We've been talking about the architecture. Cyrus is an expert in this. We've got Joe Paymer, who's the dev lead of the team. He's great at this, but it's going to take some time. We're kind of a victim of that. It's pretty successful, and we're catching up to that. So right now it's the pessimal thing. So therefore, if you can find, so think of it like that there's a dependency graph among symbols, and then you're finding the min cut right across that dependency graph. And then if you can find that min cut and you can make a d.ts file across that cut that just shunts off some subset, some strongly connected component, you will get better perf because we'll load that d.ts file in lieu of thousands of lines that would have produced those declarations. Okay, so that's a way. Now I'm curious, Luke suggested something that I was actually working on today and I got working, pretty much, which is, would it be helpful if we had a feature that would allow you to validate that some subset of your code implements fully a d.ts file so that you could keep it in sync? Like, in other words, if you make that firewall across the min cut of the dependency graph, then you've got to make sure that the code that
or even if you're going to produce a library and this is going to be your extended or your intended public surface, that the one feature that we don't have right now is validating that you're actually implementing that.
Right. So I wrote a prototype of that today, and it seems like we could get that going, but I'm wondering if people would find that useful.
So that would be like defining that you are implementing the classes, not just the interfaces as well, too, or
the whole API surface area defines.
It would basically take a d.ts file, and it would say, does this body of code actually do this d.ts file?
Right.
But it might do more, but it doesn't.
It might do more,
but does it mean
I saw external people on the forums asking for that.
Yeah, a lot of people have asked.
Oh yeah,
yeah, I think it would be useful.
It would be very useful for our use case, which is we are using the AMD syntax, and we have the modules, and because modules currently do not have interfaces, we want to be able to swap different implementations of a module at runtime. So we want to make sure we have a d.ts and people who are writing different implementations get feedback that they have implemented it fully. So I think that would be
that's a helpful scenario actually to know about. So we'll try to test that and make sure that works if we can. I don't know what milestone we could get that feature in, because we are going as fast as we can right now, and we're really trying to focus on scalability because we know that's a huge thing. But we'll try to fold that in and get that feature going. So that's kind of short term, break it up as best you can. Long term, you'll still need, when you get to tens of millions of lines of code, you would still need to employ that strategy. But up to a million plus lines of code, we should get, the incremental compilation strategy should work.
If you have more than 1 million lines of JavaScript, then there's probably something wrong.
Then you're SharePoint.
Hi, I was just wondering where conditional compilation is on the roadmap right now. We have in Xbox Music and Video a lot of, secret stuff that we kind of don't want to get released out there to the wild.
So you mean like an if-def?
If-def,
kind of
yeah.
Mm-hmm. Yeah, so we don't have any if-def mechanism in TypeScript today. We haven't looked at it yet deeply.
I think it's on the no list right now, just because once you let that devil in, it's a lot of things get more complicated. I mean, like the IDEs get more complicated, like parsing, producing ASTs, incremental updating of ASTs. I mean, we know from our other languages that it's non-trivial. So as long as we can keep it out, we'll keep it out. So there'd have to be a bit of a crescendo of demand, I think, more than we're seeing now. I think I'm wondering. Could you use CPP, or do you use CPP or anything right now, or what do you guys do?
It's just a WWA app right now.
Okay.
But in your JavaScript code, you have some solution for this already?
Yes.
Use some comments and then some
I think
script.
we're using Ajax Min right now.
Oh, so you're going through a minifier?
Yeah.
Oh, I see. Well, so that's potentially solving a different problem, is it? Or?
Yeah, well, kind of what we're trying to figure out is how far we should take TypeScript. And that's, I guess, more of the meta question here is, does this replace things like Ajax Min for us? And, how far should we keep going with it?
Yeah, okay, so that's a good question as well. So one of the things we've talked about a lot is whether for minification we should try to have TypeScript be a tool which you can plug a minifier into the back end of it and just use the two TypeScript tools together, or whether we should try and bake a minifier into TypeScript itself. We had been working more on the sort of former, had been our assumption for a while. I think as we've looked more at the problem space, we're leaning a bit more towards we might likely add some minification capabilities into TypeScript itself. For a few reasons. One is we have a lot of information, obviously. We have all the type checking information. And some of that is things we can use to do better minification. And the other is that because of things like source maps and other pieces like that, it's very helpful if you just have a one-stop shop for getting from source code to output. The more tools you have to go through, the more you have to arrange for how those source maps flow through and all these kind of things. And so we think that it's probably just a simpler experience if we can just hook those in together. There may still be cases where if you have specialized minification needs, you want to go through a second phase minifier for those. But at least core minification at the level of what Ajax Min does, I think is something that right now we think is probably going to be something we pick up, but probably not right away either. So.
Other questions?
So you mentioned earlier that there had been like several dozen forks. I don't know enough about the community and how that works to know, but are you able to see what they've done with the forks? Is anybody doing anything kind of interesting, and how are they embracing it?
So I haven't seen any forks that like go and add new features in. I think most of it is, just the way that Git works. It's very convenient to create a fork of something just so that you can play around inside it and explore it and things. And so I think most of the forks are just people like using to just play around effectively. We have seen, though, a few of the forks have been the things that people use as the foundation for building some of these build integration tools and that kind of thing. I think the fact that it's been open source has made it much easier for people to figure out how to go and integrate it into a build system or into a compilation pipeline or into Ruby or whatever. And so I think some of them have been, I know that the fork that the Cloud9 guys took has been itself forked many times on GitHub. So,
Okay, while the mic's getting passed, I have a quick question, hopefully quick. Is there any plans for supporting generics in the near future?
It's what we're probably going to do first.
Okay.
And we're working through the design right now. It's looking good, I would say. I think we have pretty much, I think in broad strokes we know what we want to do. There are a bunch of details that are not ironed out yet.
Okay.
But I think generics are one of the things that we will almost certainly do. We will almost certainly do some changes to allow more control over namespacing of everything, so the ability to put, to better namespace types and modules and classes. Like there are patterns where, for example, classes have other, or constructor functions have other constructor functions as properties, or functions have other things as properties on them, and we make that a bit complicated to do today, and then we'd like to make that easier. We've talked about overloading on constants is a feature that I think is likely to happen. There's a lot, it's a common pattern to say, when you pass the string blah to this function, it gives you back a such and such, and if you pass the string this, because strings are sort of the enums of of JavaScript, if you will, like create element of div will give you back a certain kind of HTML or element, not just a plain element. And if we could overload on that such that you specify that in the declaration that there's an overload, and when this parameter is div, then you get this and whatever, then we could do better.
Yeah. Well, you mentioned enum support. I know that there's experimental support for enums, but
it's going to change. The enums that are in there right now, be forewarned that if you use them, we will break your code, because we have another design that I think is much more in tune with how JavaScript views enums, where the enum values can be strings. We will also still support enum values that are numbers, but one thing that very likely will change is that enums will be purely a compile time thing, and they will completely evaporate, and we will inline their values such that VMs in turn can do better code generation for switch statements and ifs and so forth. And that's sort of where we feel we could add value, or more value with enums. I think those are sort of some of the headlines.
And right now we're experimenting with emitting a comment. So when you go ahead and substitute that constant, you get a comment that says what enum member it was, so you can, which obviously if we were on minification setting, we would not put it. The other thing about enums is the syntax will probably change from equals to colon to be more compatible with JavaScript syntax like object literal syntax, where you would have, Monday colon 1, Tuesday colon 2, instead of Monday equals 1, Tuesday equals 2. So we apologize in advance for breaking enum declarations in that way, but we thought about it a lot and took a lot of feedback from a lot of people on this, and it's going to line up really nicely with the overloading on constants to have enums that have strings in them, because you can think of the string as basically an anonymous enum type with one string in it, and so it kind of all folds together. I was just doing a thing with in TypeScript with a protocol, and the overloading on strings would be fantastic for that, because there's a member of all of the protocol packets that's a command, and the command is a string, and so it'd be great. I could just have I could just run everything off that string to figure out what kind of packet it is, right? So, that's easy.
Awesome. Next question.
When will we have fxcop style validation support for TypeScript?
So there's some experimental stuff in the compiler already that Steve did that gives you a few sort of JS hint style kind of feedback. So I forget exactly. It's 5 or 6 rules. No, it's actually more than that. It's
about 10.
10 rules, yeah.
Triple equals and use before def. Various stuff like that.
So we have a few of those in there. I think the work to actually turn those into a real feature that we can make easy to use and integrate into tools and that kind of thing is going to be a little bit off. That's probably in the spring of next year that we're looking at that. But yeah, it's something that's definitely also been something we've heard a lot about from teams internally and now also from teams externally. So we definitely want to have some amount of that support in there. One of the nice things with source maps that now that we generate them is that in principle, if some of these tools like JSLint or JSHint or JSCop internally, if they chose to use the source maps, they could actually provide their feedback like against the generated code and then reverse map it through the source map and tell you how to display it back onto the original TypeScript code. So by doing source maps, we have unblocked some more tools integration opportunities there, but the actual, we think to do it right, we're going to have to do it ourselves. But that is something that's a little bit further off.
Is there a plan to expose the API of the parser? I know there was some talk about this before.
Well, it's all JavaScript, so it's there's not much we can do. It's all there. So it is. So the compiler API, is there. But we absolutely will be changing that API. So we know that there are teams internally who are using that for various tools. We're not saying don't use it, but if you are, be aware that it is going to change, and those tools will need to get updated as you do. But yeah, it's just a JavaScript code. I think we want to do some intentional design work on that API so that we can allow tools to use it more directly. But a lot of this infrastructure work we need to do around performance and things is going to change the shape of that API dramatically, and so we're waiting until we've done that work.
Just want to mention one analysis check. The Monaco console in love with is implicit any.
Yes, yeah, that's actually a very important
we
one.
do any hunting these
Yes.
days, right? So our team hunts for any's,
Yeah.
and we warn them in Monaco with green squiggles. So because otherwise you don't trust reference circles, right? So
Yeah.
Is everyone familiar?
Refactorings can't really be trusted.
Is everyone familiar with the flag that Eric's talking about?
No.
So there's a style thing you can turn on, and basically, it whenever we infer any, it puts a squiggle. It reports an error. So, like if you give a parameter without an explicit type annotation, that's an infer any. Or if you declare a member of a class without any kind of initialization or type annotation, that's an inferred any. So you can go into a mode which the Monaco team has gone into where you hunt down and ferret out all inferred any's out of your code so that you know that you've got a complete type flow and that you're not missing stuff. And early feedback on that feature from the Monaco team and a couple other people has been really positive. So that's a good lint thing. But just to sort of answer your question, like there's a couple of things. One thing is pretty much everything JSLink can do is pretty easy for us to do. So there's no problem exposing all that eventually. It's just that everything is behind scalability right now. Like scalability and generics, like we want to get those two big rocks in before doing things like formalizing the compiler API or working on features like hinting and stuff. I also wanted to acknowledge the TFS team that did a fantastic job using our compiler API to build their converter and managed to convert like over 100,000 lines of code in a pretty short time. It was pretty amazing. So that shows that there's a lot of promise for using the compiler for tools in the future. Just has to be behind scalability and finishing the language. Those are the two.
What did they convert?
TFS, WebAX, can...
JavaScript to TypeScript.
Okay,
Well, JavaScript with type annotations in it, right? That you could, yeah.
Partly type annotations, partly incorrect.
Do you think that...
on that topic, like if one wants to think about like the script sharp thing, there's a lot, right, in Office, as I understand. Is there interest in thinking about how to take that, or conversion, language conversion for
Heck yes. So we, very, very early on, we met a lot of times. Luke and I went over there a ton, actually, and met with, SharePoint and the Office people. And even as early as like 3.5 years ago, I was talking with Peter Engrav, who at the time was the head of the Office WAC stuff. And so, we want those code bases. We expect to get those code bases eventually. Their dev managers want this. All those teams have expressed that it would be far better from a stability standpoint to just use TypeScript, and then they wouldn't have to have their own tools teams and so on. And so the desire is there on both sides, but they have a lot of processes built up around things like reflection, where you write it in C# and then you load it up, as a .NET thing, and then you reflect over it, and then you generate more stuff. And, these are serious teams doing a very serious thing. And so you know how that is with any team like that. They build up a set of stuff. And so, ironically, the very teams that could most use at-scale JavaScript development tools have found a way to do at-scale JavaScript development, and then we have to work with them. So I would predict that those things are going to take time. And for me, I'm waiting to really full court press with those guys until we get the scalability work done, because just kind of like the 600,000 lines of Office WAC code we aren't really ready to do. So that's kind of the roadmap.
Do you think that TypeScript will always compile to basically a text document that then gets parsed again by the web browser as like JavaScript, or do you think it could ever be like, I think with Google Dart they were trying to make some
technically it could be compiled to anything you wanted. I think it's really more a question of will there ever be another way of running JavaScript other than from text. But the reality is, actually, if you look at it, that's not really where the bottleneck is. It's not like IL loads all that much faster. And sometimes it loads all that much slower because it carries a lot of metadata. And I think, I've actually sort of been fascinated by this combination of rich metadata at development time that completely evaporates, and you're down to something that you can minify, and that's about as compact as any bytecode would be. And VMs don't really have a huge problem going from parsing and to code versus going from IL grokking to code. It doesn't make the biggest of differences.
Yeah. So some statistics for you. The Chakra engine, its deferred parser runs at 3 million code lines per second. So just brace matching to find where the function begin ends are and everything, which is all we do when we first load code, happens at quite a rate. And then what happens is then when you actually call the function, we might parse the function body and so on. So there's in terms of application startup, the lack of metadata actually more than compensates for the textual nature.
But I do think it's reasonable to think of JavaScript as the IL of the web. It just so happens to be legible, but it really is, you know.
Well, one thing I would say on that is, though, another view on your question was like, would we ever do like Dart does and build like, a dedicated VM for this kind of thing, or bake this into IE in some way? And I think we're definitely not. We didn't design this thing for that goal at all. If you look at what we designed, the design goal of being a superset of JavaScript and so closely aligned with JavaScript semantics wouldn't make sense. If we were planning on baking it into a VM, we would design something which leveraged, which got rid of some of the problems that were perceived with JavaScript and addressed those at the VM level. And that's what Dart did. Dart was a much more, it was a much bigger step away from JavaScript because they were designing, given the assumption of a new VM scenario. So our design point has been solidly around targeting JavaScript as the runtime environment of the language, and we don't have any plans to go away from that.
It seems that the browsers is the biggest target for Node.js. What about, or for TypeScript? What about other platforms like Node.js in particular?
The way that we've designed TypeScript so far has been fairly agnostic to where you run the JavaScript. We haven't really coupled TypeScript into any particular runtime environments. So we do, in our samples, if you've taken a look at them, we do have web samples and Node samples and the Windows 8 sample there. So we are showing off some of the different places where you can run this. And in principle, you could go and run this in, whatever other, on Firefox OS or whatever it is called these days.
On your Raspberry Pi, whatever.
But so anywhere where JavaScript runs, you ought to be able to use TypeScript. And I think that's been an important goal to make sure that we're really true to that idea that it's just JavaScript runtime semantics. One of the things I think we will be investing in over the next year is building better end-to-end experiences against a few of these platforms, especially in VS. So having a better end-to-end experience around Windows 8 or ASP.NET or whichever ones we decide to target in whichever order. Node.js, I think there's some pieces of work we need to do to have a really great end-to-end experience there. And we have a few of those that we're tracking, but right now it's definitely usable for Node.js. It's just there's probably some things that we'll do to incrementally improve that over the next year.
Right. Do you guys think it to support extension methods like C# has? You could get kind of same thing with prototypes, some prototypes, but without pollution. The other day I was generating a declare file for RX framework. So
I think I don't think you'll ever see extension methods the way they exist in C#, where they are sort of an illusion, right? That is just sort of brought into scope, and then we just rewrite it. In some ways, we have extension methods already because interfaces are open-ended, and you can just declare new members on an interface. Now it's up to you to then also get them onto, say, the prototype of whatever implements that interface. But you can do that. You would be able to do that if classes were extensible, which they currently aren't. But we will likely, as part of the work we do for the final release, I think we're strongly leaning towards making classes extensible such that you can just declare, such that a class declaration is really like an interface declaration and a constructor function sort of rolled up in one language construct. But really what comes out the other end when you declare a class is an interface and a constructor function. Right now, that's kind of how it is, except that interface has a brand in it and we restrict you from doing certain interfacey things with it, and we would likely just generalize that more and make it like, And so some of it...
But we aren't, currently the leaning we're doing is not toward where you would say class again and add more to the class. It's leaning toward extending a class with an interface. So if you wanted to do a mix-in, you'd still have to get the stuff on the prototype yourself, basically.
But that you would be able to do without getting type errors, just by declaring the interface with its additional members, and now magically they're on the prototype, and now you can just say, blah.prototype.whatever, and then assign functions.
In the constructor function, the prototype member, if I assign something.
Yes.
But the TypeScript doesn't have me at that point right now.
Well, it actually actively fights you, right? Because it doesn't let you put anything there that you haven't declared, but this would allow you to declare it. And then you could go put it on there. Yeah.
Okay, so let's do one more last question, and then then we'll switch.
We ran a little bit late there, I guess.
Great discussion.
I did not see any questions from the peanut gallery, although I don't consider you the peanut gallery.
So I watched your build talk, Anders, and it was very informative, so it helped me out a whole lot. The unfortunate problem was the video cut off all the end bits, like Q&A and sort of reaction, and I was kind of wondering if you had any insight on how sort of our traditional developer community responded and what their feedback was.
Yeah. I would have to say, not just from build, but from the whole the week of rollout we did in Europe. It's been a lot. I mean, just as positive as we could have possibly hoped for. And I think because we've all sort of been in the .NET ecosystem and designed languages in a certain way, it feels very, very natural to anyone who's been programming in .NET. In a sense, I think maybe you made the analogy that CoffeeScript is to CoffeeScript. The relationship between CoffeeScript and Ruby is kind of like the relationship between TypeScript and C#/Java, right? It's if you know C# or Java, TypeScript will feel very, very familiar to you. But it stays true to JavaScript, right? And I think that's the important distinguishing factor from, say, Script Sharp, for example.
And Andrew, maybe you also want to characterize how many of the .NET users group type people are actually writing in JavaScript.
Well, I mean, we asked, right? I mean,
it was like
show of hands, and it's
80%
like
of the hands.
Anyone who's writing .NET code today almost invariably comes in contact with JavaScript one way or another, unless they live in a bubble, right? And few of them do because they do real work in the real world. So it's very relevant, and I'm very encouraged by what I've seen.
I have one quick question. When you're evaluating the top 5 incremental compiler developers, is there like an arena involved with that?
So basically, I'm just very loyal, so now that Cyrus is on our team, he's the best.
Well, we don't want his head to get too large. No, Cyrus, for those of you who don't know him, has been on the Roslyn team, on the C# team, and then the Roslyn team. There was a little stint at a competitor there in the middle, and has done fantastic work on the Roslyn C# language service, and is now going to come replicate that in TypeScript land. Yep.
Okay. So since we're running a little bit long, Karen, who has done a wonderful job of organizing this, had a fantastic suggestion. Let's take a 10-minute break, go and get drinks and food, and then come back and we'll start the demos at 4:30.
So let me show you how that thing works. There we go. It's not the optimal resolution. Okay, so this is how it looks like when you launch it. It's just a web app. If you go to touchdevelop.com/app, you see it, and it shows me my scripts, and here it shows me, for example, the scripts that some other people wrote. So there's a couple of the ones that really work well on a tablet form factor that we selected. So you can, if you don't have it installed, you can install it, and if you have it, you can just run it. So this here shows a bit of code for that particular script that someone actually wrote on the phone, and you can actually clearly see that it was written on the phone from the form factor, right? So this is a game that someone wrote with a single finger on the phone. And here you can see the code, right? So let's see how actually creating code in that environment looks like. I'm just going to create a script. I'm not touching the keyboard, by the way, right? This is touchscreen here. So it starts up with an empty, well, pretty much empty method. If you run it, I get that, right? So let me just delete that. And instead of that, I'm going to go to my media. And here you can see down here there is an IntelliSense. So I know I'm in media, so I can create a landscape board. And then I want to store the result in a variable. Then I take that board, and now I want to create a sprite on it. So I can try to find the create ellipse sprite here, or you can just go here and type or use the on-script keyboard, right, to find the thing that I need. I want to create an ellipse sprite on the board, and then I take that board and post it to the wall, so display it on the screen. So I run that, and there is like a little ball in the middle, but it's kind of hardly visible because it's white. So I can just go here, I can store that in a variable, I can take the sprite. So we can see that I can really program that things fairly easily without using the keyboard, right? Okay, so now let's do something slightly more exciting. I make the, well, let's take this board and set the gravity vector on it. And now I'm actually switching to keyboard, right? So you can see that it actually works with both. 500 pixels per second squared. And then I take that board and put it in a global variable. It created a global variable for me. I can create an event, game loop event. So it's going to be run every frame. And then I can take that board and say evolve, which evolves our physics engine, and take that board and say update on wall. Now if I run it, fall down, obviously. Well, we need something around the board, create boundary, run it, bounces, right? Now that's all cool. So now let's take this sprite. So I'm kind of going here and marking a bit of code, and I'm going to cut that from here and create another event. I'm going to create a swipe event. I'm going to paste that here, and I'm going to take this sprite, set its position to X and Y, and I'm going to set its speed to delta X and delta Y. I can run it now, and then if I do that, so so the thing is that that this app lets you create. It's all written in TypeScript, and it lets you create little scripts, little games, in future web apps with UI and data and so forth on all sorts of devices. It works in various browsers. It works in IE. It works in Firefox, Chrome. It works on iPad.
So on the phone, well, how do you actually run it on?
On the phone we have an app. That's different. You can actually, this isn't really optimized, the UI isn't really optimized for such a small form factor, but you can actually run it. You can take, if you have i10 on the phone, on the new Windows 8 phones, it runs just fine. But you cannot really use it because the things are too small, so we didn't really put enough effort. You can use it on like 7-inch device, but 4 inches is a bit too small, so we kind of need to put some more work in there, but it's the same environment.
How many lines of TypeScript?
Yeah, so I have another slide that shows the statistics, which is going to show up in a second. There we go. It's about 50,000 lines of TypeScript, some CSS. There is quite a bit of C# code in the cloud that was actually already there for supporting the Windows Phone app. The Windows Phone app is quite a bit bigger. It does a bit more, but certainly not 3 times more. It's just one TypeScript project, and that is getting a bit slow, especially with the IntelliSense and things. And yeah, so I actually started the rewrite from the Windows Phone to JavaScript in October, and then in JavaScript, and that didn't go so well, and then in January we started in TypeScript. Well, it's, first of all, you need to come up with which way of doing object-oriented programming are you going to do. And then, well, of course, you come up with all sorts of clever way of how you are going to do that. And then you make a typo somewhere, and then it crashes, and you have no idea. And then, yeah, the usual things, I suppose. So actually, TypeScript make that much nicer. Yeah.
Awesome. Okay.
All right.
I forgot to mention that the first two demos we're going to see are like projects that were built using TypeScript, and then we'll get into a couple of demos about like tooling around TypeScript.
So I'm Dan Marshall. This is Todd Newman. We're from Fuse Labs, and I'm going to show you Socl. And this is a large-scale application with a lot of JavaScript on the front end. So we're kind of an AJAX front end, a single-page application. If you know what that is, that means that we have all the JavaScript in page. We don't hit the server to reload our HTML. We do everything after the hash in the URL. So all the JavaScript is already there. So you're here at a great time because we can show you the before and after TypeScript. So I'm going to go ahead and give you a demo of what we looked like before TypeScript. Just to give you an idea of what Socl is all about. So how do I get this on the screen? Press stop.
I need to get it out of presentation mode. Escape's not working.
Let me alt tab to the PowerPoint and then hit escape. There we go. Okay. Burned about 30 seconds there. So here's Socl as it is today. This is before TypeScript. So what we have is a social network, and what's really exciting, this is like Fuse Labs' answer to something new in the social space. And what we did is an experiment with Bing. What would it be like if you wanted to share your search results? So it's really exciting to be playing in the Facebook, Google+, Pinterest kind of arena here of social applications. So what ended up happening with our experiment here is we ended up coming up with more or less an interest network. So I'm going to choose an interest here like architecture. So what we have here is a stream of posts coming from real users all around the world, making really compelling, interesting posts and interacting with each other and this on the topic of architecture that we chose here. So what I have is a stream here. What you see is each user making a post, a collage of images, a collection of links. Everyone can like it, comment on it, and when if what we have is an awesome back end with JSON objects of the data coming back and forth. And those JSON objects have kind of a schema that's wired to the front end here. Now, if we have a kind of a small schema change, first name now has a capital N, or maybe it has switched to a lowercase n, that ripples out throughout all of our JavaScript. And how do you fix that? Search and replace. And sometimes you'll reference a JavaScript property with a dot notation. Maybe you'll reference it with a bracket quote notation, and so it's really loose. And so we could spend hours debugging a really simple thing like a schema change. Now let me show you Socl after TypeScript. So what we did is we redesigned the UI. So
TypeScript didn't do that part for us.
TypeScript did not redesign our UI.
Did it mow your lawn?
So we're about to launch this in a couple weeks. We're totally excited about this. We have more of a masonry layout here, but now that we're using TypeScript, it's just, we have this whole class of bugs that's no longer an issue for us. We have well, Todd's going to talk about what our team looks like and how many devs we have and everything, how many lines of code. But just a whole class of bugs just are not even in a problem for us. Now we have a new class of bugs. No, just kidding. I could basically we have here our demo environment, so it's not quite as compelling. We don't have worldwide users hitting this data. So a lot of these posts here are just made by our test team, but we're going to be launching it in a couple of weeks. So,
Can I hand off?
Yeah.
Okay. Yeah, okay. One of these is going to be it. You see every single app Steve's ever run. Here we go.
Press F5.
Pardon? See, his keyboard's new for me too. Okay, and then the clicker. So many controls. Demo. Okay, here's where we are. So, as Dan said, Socl we started writing in the spring. The UI is entirely done in TypeScript. We have about 30,000 lines of code. We have 7 full-time developers. So one of the things I thought TypeScript was really great about was that with all those developers, having strong typing made it a lot easier to make your intentions clear in the code. Using interfaces to define what APIs are supposed to look like, it was just much easier than writing in raw JavaScript. We have, since we do have 30,000 lines of code, we don't have one really long file. We have hundreds of source code files. We did not want to have each one of those files downloading separately, so our solution, not knowing about ATM, was that we wrote a special packager that packages up all of our files into one master JavaScript file that we then download. And the packager also handles some of our cross-referencing issues. The JavaScript has really helped us, or TypeScript rather, has really helped us with code reuse across projects. We're able to reuse about 80% of this code across the Socl project, project we're working on with Bing, and we were doing some test development on Windows 8. So it was really helpful for all of that. Besides writing our libraries, we're trying to contribute to the public good, and one of the things we did was, under Steve's leadership, we have developed a framework that we call SCORE, which is loosely modeled on .NET, and it's essentially some utility code that a lot of UX developers will want to have. There are .NET style events, there's iDisposable. We use iframes as the way we communicate between each of the little separate apps and our overall header and keep track of the different modules within Socl. So we have a framework developed for communicating between those. Some of the most common controls like text boxes, we rewrote, put some wrappers and UI functionality around it that we think other people might want to use. A unit test framework. So all of that's in SCORE and is shareable. So to summarize what we found, TypeScript really did make the large JavaScript jQuery project a lot easier for us to develop and maintain. Doing it the second time also helps, but we learned a lot. But yeah, definitely doing it in TypeScript was much easier. And all the code that we have and all the tools that we've developed are out on CodeBox for people within Microsoft to reuse. So TouchDevelop has the full everything, all singing, all dancing, all the bits you might want, and the SCORE stuff specifically is in CodeBox SCORE.
Awesome.
So are there any questions? Anybody?
So you said you have 300,000 users. Who are they? Or what do you...
It's fascinating. It's a worldwide audience. We put this up and we said, we were originally thinking, well, we'll just introduce it to students and build it small. And they told their friends and they told their friends. So what's fascinating about it is that unlike most, it's sort of like Twitter and less like Facebook, that you get everybody posting on everything and then you sort of tag by interest. So we have people in Japan, we have people in China, you get posts in Russian. It's a really interesting broad mix.
And because the posts are so visual, we end up with a very international flair because it crosses language boundaries.
But the thing that ties it all together is beautiful imagery, is it? Or
web links? It's imagery, and there's a notion that you can tag a post by topic. And then if I can flip back and make this work, I'll show you. We have these notions of interest groups.
Show creating a post. You guys didn't.
I think you've got to escape out of PowerPoint mode.
Oh, that again.
It's also great because it transcends time boundaries too, because you're up at 3 o'clock in the morning, well, that's someone else just having their breakfast across the world, and you're having this kind of conversation with them about...
Is it escape or F5?
Escape.
There is no escape.
There is no escape.
So are you using a module system to structure your code? How is your code organized?
Yes, we use .NET style namespacing. So we have modules, but they're not exported. So they're not AMD modules or anything. But we do use a namespacing type of architecture to structure. I mean, one feature that we would like to see added is the ability to combine multiple files into a single AMD module, because then we could kind of look at potentially adopting that pattern.
Todd, create a post. It'll make it
Yeah. Somebody come up with an interesting topic.
Election.
Yeah.
2012.
Whoop, nothing's going on with
TypeScript.
that. Nothing's going on with that.
Yeah, we didn't mention that we're using...
TypeScript might not have a lot of compelling visual.
So what we're doing here, so this is a Bing search in the right-hand column. And I can take this and I can add items. I could add some text. I can add some pictures. I could say, hey, wow, these are... I want to get different, better images. So I can go out to Bing and get some weird, interesting images to add. And it's a little hard to see now. These are all going into my post. I could go back and look for more election videos, throw those into the post.
We're actually working with the Bing team as a test to build this directly into the Bing social pane.
And then when I say post, it drops that back into that mainstream. And then I might tag it and say, oh yeah, I really should tell you this is about election. And now what we've done is we've created an interest group on elections and people can post on it and recognize it. We do, of course, have these standard social network things like you can like a post and you can like your own post, just like in real social networks.
Awesome. Okay. So now we'll transition to the tooling side of things.
Okay, hello everyone. So I'm Randy. I'm over in Socl all the time trying to make big things with TypeScript like the rest of us. And a project of mine called JSLink has been helping us do that so far. So JSLink is a build and project system for TypeScript and JavaScript built on top of MS Build. Now it's that last part that has actually been kind of the most compelling. So today I'm just going to address some of the key parts of what that means. No demos because watching things build is, we all get tired of that. So first off, project-to-project references, including references from managed projects such as an ASP project. Cross-project IntelliSense through those references. Building your JavaScript and TypeScript assets such that they become bin-placed, show up as content in an ASP project, including if you're going to deploy the ASP project to, say, an Azure web role. Specifically for JavaScript, since there's separate but similar support for TypeScript and JavaScript, combination of JS source files in some kind of dependency-like order to manage your smaller source files for you. So what do I mean by project system, and why do you want one of those? So I'm curious by a show of hands how many people have a very substantial amount of code in one monolithic, perhaps very scary ASP project that kind of runs the whole world. I've found that to be true. I started that way. Eventually there are kind of some growing pains there, especially if you're in straight JavaScript. I was talking to someone today, how many script tags are you managing in this one view because you want small files, but So in this example here, this is actually the structure that we're using in practice, where we have some blue boxes for some TypeScript projects, but with edges indicating project references like we're used to, where the red one's interesting, an actual managed project, but referencing TypeScript, which references more TypeScript. Splitting out the projects in this way, though, not everything is tied to ASP, right? You have a reference at build time from your unit test to your product code, and run the tests on that. So the typical decomposition that we're used to. So as a consequence of building on top of MS Build and making very particular decisions there, the references that I'm talking about work just like they normally do. So this means that you get integration with tools including Visual Studio and command line builds and such. If you want to add a project reference, you use the VS context menu. Even if you're adding a reference to an ASP project, just pick the project which represents TypeScript in your solution. So the decomposition that I'm talking about here wouldn't be worth very much if there was a big cost to it. So a must-have here was to get cross-project IntelliSense as you add these references. So as you add this project support, not only does it copy the built content from all the projects as you would expect, but also generates as necessary supporting files for cross-project IntelliSense into, as you'll see in the next examples, a special directory called reference support. In this case, we have some arbitrary ASP.NET view where we have a library called Penzance. So you add an IntelliSense reference tag to under the reference support directory to, in this case, the JS file, since we happen to be in that kind of editor for the Penzance project. At that point, as you see there, we have IntelliSense showing up for one of the Penzance namespaces. Similarly, so for TypeScript, with the additional trick that the ability to generate declarations thanks to the TypeScript compiler is invaluable there, that kind of connects to one of the prior discussions about perhaps manage these longer build times. A fringe benefit here is that, say, your product code, if you're referencing it from some, say, unit tests, perhaps you'll be doing less parsing for the fact that what you're referencing within your unit test TypeScript code is actually the declarations file for the product code, which is generated on build only if the files change thanks to MS Build. So I'm about to segue into out of TypeScript land, even though I'm at this meeting, just from the practicality that there is a lot of JavaScript code in the wild out there that people need some help with. So although TypeScript and JavaScript play well together in this system, when we do not have the TypeScript compiler available and you are dealing with straight JavaScript here, there is JSLink support for combining files, plain JavaScript files in some kind of way, to allow people to have smaller, more semantic files without having script tags all over the place. Much like the TypeScript compiler, this is by piggybacking onto the IntelliSense reference tags so that more or less you get a correct build so long as you're getting good IntelliSense too. There are 3 different configurations when doing this. Release build, single file, it's something you might want to distribute. Debug build, since we don't really, no source map support here, the trick instead is to generate a debug loader which will use the same dependency ordering information and insert the scripts at runtime. In place being exactly the same except with the additional trick to construct a relative path all the way back to the source tree. So, you get all the delights of the build system here, but so long as you don't add or remove files or change dependency ordering, maybe you can just save your changes and refresh in the browser and see them immediately without an intervening rebuild. So here's an example of that with a lot of files in the Chrome debugger that I'm really glad while I was working on this Penzance project that we did not have to add manually. So this is what a debug version would look like in the tools. I'll just have to promise that the using HTML here actually only had one reference to the dynamic loader. So if you'd like to use JSLink, it's really not too hard. This is some of the familiar kind of things that you would expect in a Visual Studio project file. Same project references, nothing magic there. Just add your TypeScript files and mark them as such. Depending on what library you're using, instead of the C# targets, now you're saying this is a TypeScript library or this is a JavaScript library. If you want support for, for some particular managed project, I want to reference a TypeScript or JavaScript library and have it show up in the right place so I can use it at runtime and serve it up to clients. Then there's another one, JavaScript reference support, to facilitate that. So as a result, you might infer that there's actually no Visual Studio extensibility used here. It's just minimal thing to get command line builds, Visual Studio builds, piggybacking on the same infrastructure. So it's available with CodeBucks now, and with that, I'll open to any questions or interest. All right.
Okay, so if we could get Chris to come up, and Chris is going to give us a demo of Monaco.
Hey, do you guys want to start while I get this plugged in? Just intro. I just got to fix one thing. No.
So Monaco started 1 year ago?
Yep.
1 year and 3 months ago, right? And from the beginning, we decided we want to grow big, and if you want to grow big with JavaScript, you need something more, right? So, and we were kind of early on TypeScript till today, and we really had hardcore JavaScript programmers in our team. So initially we were kind of defensive at 30% of our code base was in TypeScript. And recently, I guess we have grown up to over 70% in TypeScript.
Yes.
And we're really happy about this conversion. So it made our code better. We felt really like fresh showered after having gone through this TypeScript migration. What's also interesting, TypeScript usage, I don't know whether you covered that. We use 2 module systems for Monaco. On the server, we use Node.js, so we use the common JS module system. And on the client, we use AMD. And what's cool is now we really can use one module syntax to talk to both module systems, and it works. So since 2 weeks, Joe? Since when? Since 2 weeks, we really compile the whole code base without a problem. So that's 20,000 lines on the server, 140,000 lines on the client. And we run in a browser. We support lazy loading, minimized requests, and so on. Enough, Chris? Or should I start?
I made a little change there right at the end there. I don't know where the TF-EULA thing came from. I've done this before. Okay, so sorry about that, but thanks for filling in for me. Okay, so can we hear that? All right.
Yeah.
So my name is Chris Dias. I'm the Redmond-based program manager on the Monaco team. And so, like Eric said, we're going to support a year. I'll go through a couple slides, which just kind of talk about what Monaco is and how it sort of relates to the big picture from Visual Studio, and then we can do some demos and we can kind of be live. So we have a globally distributed team. So there's 4 of us in Redmond. We got a guy in Edinburgh and a guy in Zurich. Somebody was talking about being able to do discussions at breakfast halfway around the world. That's kind of how it works with these guys. Like, I'll be going to bed, they'll be getting up, and then when I get up, they're leaving for the end of the day. So it's actually quite good because we get a nice 24/7 workflow going. These are all the, sort of the things that we worked on in the past year. Right? We had a goal right at the beginning to be able to bootstrap Monaco and self-host Monaco in itself. Right? So we develop Monaco in itself in the browser. We very rarely use Visual Studio to develop any of Monaco. For a while, it was just to do some Team Foundation Server check-ins. And over time, we've added partners, right? So yes, it's a great project, but we have to have partners in order to ship something and keep it real. So we've added partners with TFS and Napa, which I'll show you some demos of. We moved it over to the AMD spec for module loading, which I think you talked about while I was hacking away here. Yes, question?
Someone unfamiliar with Monaco, could you just explain quickly what it is?
Yes, I'm sorry. So Monaco is, I skipped the very first slide, didn't I? So Monaco is a web standards-based development environment, right? So in a browser, what's that?
F5.
F5?
Yeah, for the presentation, for the recording.
Do you have it on that machine? I do have it on the machine. It's on every machine. All right. So effectively, it's a web development experience hosted in the browser with a set of services that are running up in the cloud. So I'll show you a demo of that in a second. All right, so that's a team. That's kind of what we've been working on. We moved over to module loading. But then we moved into this sort of distributed model where we're building, we call it VS Online, the whole sort of end-to-end online development experience that you could get with Visual Studio, Team Foundation Server, on the desktop and in the browser, which is a lot of things that we've been working on the past few months. We say end-to-end app development. How do we go online in the browser and actually be able to build an app from scratch, run it, debug it, test it, deploy it, and do the whole end-to-end scenario. So that's what we've been working on a lot in the past few months. When we think about the various scenarios that we have a set of core partners that pick up components that come naturally out of having an end-to-end scenario. So there's a lot of people that are using the editor just as a self-contained component. There's a lot of things in like research. Azure Portal uses it. And we also have larger chunk components, which we call the workbench. And we have one key partner using it right now, which is Office 365 tools. But those are sort of the things that we deliver as we're on our way to building an online development experience, which again we call VS Online. And in the future, much further in the future, something that we think about actually working on is taking F12 that we have today in IE, which is contained within IE, but making it an online and distributed debugging experience for Internet Explorer. So imagine that I could go through some service to diagnose your browser, running the app in your browser from my machine, right? So being able to go through a service to be able to do that, instead of having hard-coded things that are distributed with IE itself. But that's much longer out. So we're working on our partners, delivering to them, and working on the end-to-end experience at the end of the day. So do have a number of partners, Office 365 tools, TFS Web Access, Azure mobile apps, TypeScript Playground, which everybody knows about. We're working with the F12 guys. We'll actually take a lot of the pieces of Monaco editor and put that into the F12 tools in the future. MSR has a number of sites that are using the editor. There's a lot of internal sites that are actually using it as well. There's a number of people that are building language services that plug into the editor. Then they'll rehost the editor moving forward. Just a very high-level overview of sort of what the architecture, the platform looks like. So you think about it sort of like we've got stuff that's running in a browser. It's our workbench. It's the development environment, which is everything over here. We take advantage of the browser as much as we can. You know, IE9, IE10, Chrome, things like that. We use browser local storage. We use web workers to provide a very responsive experience. All of these things talk over standard REST APIs to a set of services which run up in the cloud. They can run in the cloud. They can run on-premise. They can run in Azure. It doesn't really matter. It's very standard, but it's all the sort of things you think about for a development experience, right? So build, source code control, testing, things like that. Our services talk to what we call a workspace. And a workspace is an isolated development area. So you think about your PC today, if you're doing Visual Studio, you have a workspace that's local to your machine. It's separated from your repository off in the back end. If you're using Visual Studio 2012, you can have a local workspace. The workspace that we have for Monaco is the workspace that's sitting up in the cloud somewhere that's isolated from everybody else, right? And so you want to do your development in that space and then at some point push it to your production, your truth at the back end. So we have our workspace service that we're building out right now. And of course,
and this is on Node.js, right? That's Node.js.
Yes, this is currently, it's running on Node.js as just a standard service. And then, of course, all these services also integrate with the other services that we have from Team Foundation Service, so like build and things like that, all come together into what we think of as VS Online.
Chris, one comment on what's running in the workbench.
Yep.
The language service for TypeScript is the same language service as used in Visual Studio, right? The TypeScript language service is written in TypeScript, so we can actually use the same API to implement the same experience in the browser. So we stand on the shoulders of the TypeScript infrastructure here.
Yep. So these are the old statistics. I didn't get in the ones that you just sent me, which are slightly
I rounded up.
No,
I added the tests, right? That's the difference between use. We have also our unit tests written in TypeScript, so that's the difference.
So heavy usage of TypeScript, and I think we said before, we've been very, very early on adopted TypeScript and rode along with all the changes that have come on, but the net result has been huge increase in productivity throughout the course of the development process. And it's interesting.
One recent case study, right? We had to support DBCS in the editor. And DBCS in the editor means you have to touch lots of locations in your code because it totally changes the assumptions you make. And I would claim without TypeScript support, we couldn't have this migration to DBCS in the editor. It would have just been death.
Yep. Okay, so enough slides. Let's go do some demos. We're going to look at sort of Monaco Tools as the portal, which you kind of see the platform, so the core pieces of Monaco Tools. We'll see how partners are using it, and then we'll try to do some end-to-end development if I didn't screw it up too much on my machine right before this. Okay, so any questions so far? Did I answer the what is Monaco yet? A little bit? All right. There's a little cart and horse problem with that, but we'll get it all figured out at the end of the day. Okay, so first thing we do is we built this portal, right? It's like any platform you can have a portal. And the reason we did this is because we wanted to sort of learn and understand and get a sense of what it was like to go have a portal that people consumed the Monaco tools in. So we think of a couple scenarios with an online development experience. One is helping our Microsoft platforms have an easy on-ramp to developing apps that use those platforms. So you can imagine, like if I go to Office 365 and I want to do some development in Office 365, I should be able to go there, create my project, start editing it, start building the app right away. If I go to Azure, I should be able to do the same thing. And so we built a portal so we can go and do the same thing with Monaco. So you can come in here and everybody's free to go and come in here and use this. And we actually do use this to get people to learn how to use Monaco and get the bits and everything. So you can come in here and you can click on try. And there's all the different parts of the Monaco platform that you can try out. And so the first thing that we'll show you, which this will really put a fine point on what is Monaco. We're going to go and look at the workbench. And so the workbench is the whole end-to-end development experience. And it's running on a server. It's our on-premise server. It just happens to be the one in my office. It's the easiest one to hit right now. But what I can do is I can come in here and create a new project effectively, right? We have a nice little drawer when you don't have anything in your workspace right now. So I logged in as guest. This is my workspace. This is where all my projects are. We don't have anything. We automatically give you a nice little drawer. We can come in here and say create something new. So I can go create from a template, and we'll go into these in a little bit more detail. I create from a sample. If I have a zip file of a project, so even if you have like a Visual Studio project, you can zip it up and upload it, and we'll expand it on the server into that workspace, your workspace, and you can work on it. If you've got an account on GitHub, we'll go and we'll pull from there, or just a plain old Git URL, and you can clone those things into your workspace. So let's go create a sample. We'll use the TypeScript sample that we have, which is Mancala. And so here we are in the workbench, right? So there's a few things to look at here. I'll click on a file and so show you everything that's going on in the workbench. First off, over here on the left-hand side, this is what we call the various viewlets in Monaco itself, right? And so it's the core things you need. So the Explorer, so you can see a tree of all the different files that are in your workspace. I can do a search across my workspace. So if I do a search for like game here, it'll go and it'll do a search across my entire workspace and show me all the results here that I can go and then navigate through. Now, if you remember back in that previous slide, I had, there's a set of services that Monaco is accessing. The search is one of those services. It lives up in the cloud in that server, and it's looking at that workspace and then pulling all the results back. Now, we've got sort of a provisional early on search service that we've got implemented for the tools today, and you can imagine us integrating with some of the higher end ALM stuff that's going on in Visual Studio for enterprise search. So you'll be able to come in here, not only search your workspace, but maybe you'll be able to search across, if you're at Merrill Lynch, you could search all the way across Merrill Lynch, for example, or whatever universe that you wanted to define. Build, so if you have a particular configuration in your project, and what we have is a convention, which is a build JSON file, which defines what the build actually is. The build viewlet will let you go in here and actually execute the build. So if I come in down here, it'll build it. I don't have any errors, and everything is wonderful. I could come in here and let's go break something. Break something. You'll see what happens is the file automatically gets saved immediately. The build gets kicked off, and you can see that we have an error, and I can see what the problem is. So as you're developing in here, the files are being saved, the builds are happening. And the next thing that would happen if my builds are successful is that my tests would run. So I'll save, the build will kick off, and then you see right here, which is my test viewlet, these are all the tests that we have in my workbench that get run on a successful build. And then the last thing I have is a console. Right, so again, we have this workspace. It's up in the service somehow, much like you would have locally on your machine. Sometimes I want to go to the command line. So we have a console that's looking at that particular workspace on the server, and then I can run a set of commands across that command line, across that console, that workspace. So I can see all the files that are in there. If I come in here and I type help, I can see all the different things that I have access to for within here. So I can do Git operations, I can run npm, I can do the Azure command line tools. So a lot of interesting things you can do on your workspaces you expect to do locally, you'll be able to do them in the cloud. Okay, so that's kind of like what you can do with the workbench. There's a few other interesting things that I want to show in here. We support different theming, so you can have a dark theme and a light theme. If you want to create your own theme, it's just a bunch of CSS, which is the beauty of standard web things. I can go into a distraction-free mode, which gets rid of the viewlets and sort of gives you full space for the editor or the whatever editor you happen to be in at the time. So if I come over here, I hit on a file, I hit escape, and now I'm in distraction-free mode. So I can really focus on the code that I have at hand. There's a lot of different things we can do in here. You can move the sidebar to the right-hand side, sidebar to the left-hand side. It's all persisted in browser local storage. And at the end of the day, what you get is a nice customized development experience. Yeah?
So for debugging, are you still dependent upon like F12 debugging within the browser?
So there's two things. So the question is, are we still dependent on F12 to do debugging in the browser? So there's two things. One is, yes, you have to do F12 debugging on the built application. Second is we have a very early prototype of being able to do debugging inside Monaco of a Node application using the WebKit APIs, right? That
V8.
The V8, yeah, the V8 engine.
Not inspector.
That's actually the third thing too, is we do hook it up so that you can use Node Inspector to go against a Node application as well. So we have different levels.
The client has to be debugged with the browser, but your server-side Node pieces have to be, it can be debugged within Monaco.
Yep. It's very, very, very preliminary what we can do in Monaco, right? And then if you're using a Node app and Node Inspector, it's standard WebKit.
Right. There are other tools out there.
Yep. Okay, so.
Language service feature.
No, I haven't even gotten to any of that goodness yet. So let's go back over here. I'm just trying to optimize the time. So it's 5:16. Everybody have to leave? Everybody want to stay? You got to go? You've seen it before. You can go. Okay.
Let me add to that there's the alcohol is here for 15 more minutes. So if you want to sneak out and get another drink.
Yes. Everybody.
Good presentation. You dropped a drink.
Okay. So let's go back here. So we've got. Let me move back to. So there's a lot of things. So as Eric said earlier, we actually use the same TypeScript language service in Monaco as we do on the desktop. So that starts to give us lots of interesting things. So I can come over here and I can click on game. You see a little glyph that comes up, and I press Control Dot, and this will give me a set of things that I can do. So I can see I can say view declaration of game, and what we'll do is we'll actually inline inside the code itself show you game. Seems like we're off a little bit. I can do things like.
Can you show
Was that an iframe?
No, it wasn't an iframe. No, it's just this. We call it a zone in the editor. So the editor supports the notion of zones, so you can.
Is it scrollable? It was like a disk?
Yeah.
The line numbers, everything.
Yeah. Okay. Cool.
Can you do
So if
the
I
same thing for CSS? That'd be great. Show the CSS.
Yeah,
You have HTML and you have CSS. Yes.
So it's a view within the editor of another file, right?
Yeah.
And so it's the full editor in here. I can scroll around here, and for this one, I did. What did I do?
When you say editor, can you edit the file in there? No, it's read only. It's read only? Yeah. But it could be
There we go. So I did show references, and so then over here on the right side, I can click through and see all the different places that it's actually referenced throughout the entire workspace. But yeah, I can't. This is read only in here. I can do things like, a rename symbol. So I'm going to call this game 2, and it'll rename it throughout the file, sort of combined editing at that point. Right? Let's see, what else can we do in here? Yep. So we have full IntelliSense on this. So if I control dot, we show you IntelliSense for the game class, and as you cycle through here, we'll show you the return type and the parameters if there are any. So for like that, we can press enter, and we actually give you tooltips for the parameters like you would see in Visual Studio. And if we had something with overloads, which we don't. So if we have something with, something with overloads, then I can press the up and down key and I can arrow through them and see all the different overloads that are in there. And as I move between parameters, we'll move you along between the parameters as much as you expect of what happens inside Visual Studio, which is very cool. We think of Visual Studio, like if you look at Visual Studio on the desktop and Visual Studio, in the browser, there's a set of what we call franchise, or we describe as franchise features, things that we think are really critical to the Visual Studio development experience that we want to have an on-par development experience inside the browser. And IntelliSense is clearly one of those. Debugging is another one of those that we'll work on in the future. But providing that rich experience is what makes Visual Studio and coding this environment great. So that's sort of some of the things that you can do here inside the environment.
So Chris, we should probably wrap things up and then we can continue.
Yeah. Okay, yeah, sure.
Okay.
So do you want to wrap it up?
Yeah.
All right, go ahead and wrap.
All right, well, so I think this was awesome. It definitely ran a lot longer than what I thought it was going to. So if we do this again, please send me feedback, right, if people want to do this again, and we'll schedule a little bit differently next time. But I think it was awesome. The Q&A session was fantastic, and I just want to thank everyone for coming. And you don't have to leave, so please continue talking and everything. I think Chris is totally open to demoing Monaco more, so we can just continue from there. Thanks, everyone.
All right, thanks.